In today's video, we're going to build a nice scene transition system along with this nice fade wipe kind of animation, and it's all going to be handled in one big chunky video. Hi, my name is Michael. Join me as we build an epic Metroidvania game in Godot 4 using GD script. This is the Metroidvania Forge. So we've got a series of levels and we need a way to transition between them. So we'll build this nice level transition scene. This level transition scene consists of an area 2D with a collision shape. It's going to be configured so that it's on a layer mask that looks for collision just with our player. And it's going to do things like allow us to change the size. So here when we set the size or the location of this transition, it's going to update the rendering of this level transition in the editor. So we can see what it's going to look like. So left, right, top or bottom, as well as the size here, right? So we can use this to adjust just how big it is. So if we have those big entrances like we've got here, we can configure that as well. Now the script also is going to handle when the player enters. So we'll connect to that. But you can see here, I've got a nice SceneManager that we're going to introduce, a global script to our project that's going to allow us to have signals that dictate when things should happen to kind of keep and help us avoid a lot of the bugs that could arise from doing a system like this. And then this SceneManager, whenever our player enters one of these scenes, it's going to send this information, the direction it is, what level they need to load next, and which level transition they're going to spawn at. We'll send that over to a global script that we'll call our SceneManager. And then this sucker is going to orchestrate the whole thing. It's going to come in here, fire off some signals. We're going to do things like fade screen using a tween and asynchronous function. And then we'll use the get tree, change scene to file to load a new scene. And all of this is going to kind of happen within here. And then, of course, these level transitions are going to have to hook back to that. They'll respond to signals like when our load scene is finished or when the new scene is ready. Then let's go ahead and do things like position the player or set up this area to monitor for the player. And we're going to build in stuff like these physics awaits to make sure that we don't get weird overlap as the player transitions between scenes. And it's going to be kind of handy. So if you want to learn how this all comes together, then stick around for the rest of the video. Okay, so at this point, we're going to go ahead and jump into making this level transition. Now, before I do real quick, if you've been following along, then you've already grabbed the icons that I've got stored here in my general icons folder. So you can see I've got one for my level transition. We're going to be using that today. So if you want that, it's not required. You don't have to have it. But obviously, if you do, and you haven't been following along, then you can hop over to the itch.io page linked in the description and grab the Chapter 2 asset pack, and that'll be in that zip file. Okay, so what we need to do, obviously, is we need to have a way, like with our player here, we need him to be able to transition. And I've set up some extra levels here. So I've got level 1. This is the scene and the level that we've been working on up to this point with this series. And I've gone ahead and made a level 2, which is pretty simple right now. And it's got a little area that drops down here. I've got a platform so that you can kind of, fall and land on it. You have to drop down through it. And then I've got a dungeon scene, level 3, which would be below level 2. And so I've kind of lined up these areas so that they kind of will match up. And you can see what I'm going for there, right? We've got the same width on these, which is kind of important, I think, especially for a vertical transition. You need to make sure they're about the same size. If this one were like really big over here and you jumped up, then it's like, what do? Do you appear in the ground, So just think through those things. And just to review, this is kind of the map. So you can see I've built this level and this level and this level here. So just kind of this little section. And I'm building the connections as I've mapped them out. So you've probably done something similar, or maybe you've already kind of started building a whole bunch of levels. Obviously, before we connect them, it's kind of hard to work with them. Now, one other thing that I'm going to say about this, and this is something that we're going to deal with later on in this chapter. Right now, we only have a player in our level 1. So you could have a player in each of these. And if you run that scene, then you'll have a player in there. Once we get to the point where we're really working with these levels, we're going to build a player spawn scene. And so you can see I've got an icon already for that in that asset pack, but that's going to kind of alleviate that issue. For now, we're just going to simply have to start in our scene 1 here. And if I go ahead and run my game, this is the only scene that has a player. So if I don't start here, it'll just be an empty map. But yeah, obviously I just fall to my death or just into the void of gray where he falls forever. Okay, so what I'm going to do before we get started with making this thing is I'm just going to drag my player over here to the side, because as we're iterating and testing, I want him to be close to the point where I'm going to be able to test. Okay, so now when I run my scene, I'm going to have my player at the far right edge of this map so that we're ready to just jump through to the next. Okay, so if you don't have levels and everything set up, then make sure that you do. Get at least 2. Obviously, I've got scene 1 and scene 2 here are transitioning from the left and right respectively. And then from 2 to 3, you know, 2 we're going down to the top of 3 and up, okay? And that's going to be important because we're going to make sure that our level transition works with those 4 different directions. So having at least those 2 types of transitions is good. Okay, for our level transition, I'm going to make a new scene, and we're going to use this scene, and we're just going to have to drop it into our levels where we want it. We could get away with making this just like our level bounds that we've made, where it's just kind of a new node type right here. In fact, that would be an awesome exercise for you to do. But for sake of simplicity for newcomers, we're just going to make it a scene, because then we have a little bit of control and we can see what's happening a little bit better, as opposed to needing to do a lot of object instantiation through code. But it wouldn't be too difficult to do that. So I think that's a fun challenge when we get done with this, if you want to make it a reusable node. So the difference being is, obviously, like this level bounds that we've created in the past, we can just add here from our create new node, okay? Because it's just like a new node type that extends from node 2D. Whereas a scene you would add with Shift Control A, and we've got scenes like our player, and you can see our levels are in here as well, right? So this level transition is going to be a scene just like that. In order to create this, I'm going to come here into my general folder, and I'm actually going to make a new folder here as a child of this. The location isn't ultra important, but for organization purposes, it might be nice. So general, I'm going to call this level transition, and then I'm going to make a new scene underneath this. So create new scene, same name, and it can have a 2D scene root type. That's just fine. And we're ready to go. Okay, so in this level transition, here's what we're going to do. I'm going to go ahead and add an area 2D. Okay, and this area 2D is going to be what detects when our player enters the area, right? And of course, we've got the configuration warning because we need a collision shape. So I'll add a collision shape to that as well. Collision shape 2D, and then we'll just define a simple rectangle shape like this. And I'm going to go ahead and color this because I want it to have a visual appearance that's distinct when I drop it into my scene. So here in debug color, I'm just going to change it. I'm using this kind of minty green color myself. You don't have to do that, but that's what I'm going to go for. So somewhere in between the bright green and this cyan color, and voila. Okay, so I've colored my box so that it's got a distinct appearance again when I drop it into my levels. I'm going to go ahead and save that. That's really all this node needs as far as child nodes and setup. Pretty straightforward and pretty simple, right? So just have a node 2D scene with an area 2D and a collision shape 2D. But we're going to go ahead and configure these real quick before we're done setting these up. The area 2D, we want to adjust our collision settings. And so I'm going to come down here to collision, and it doesn't need to be on a collision layer because we're not detecting this. This transition is the one doing the detection in this case, right? As opposed to other things detecting when they've entered the area. They don't care. Our player doesn't care if this exists or not. None of his code is going to be checking for it. So we just turn that off. And then what we can do is down here in the mask, we just want to turn on, I think layer 5 is set to be our player mask, right? And maybe not. Let me double check how we set up our player. Did we put him on a layer? So I've just moved over to my player scene and selected that node. Yeah, and look at that. He is not on a layer right now. So let's go ahead and put him on a collision layer 5. So what this means is right now the player is looking for collisions on layers 1 and 2, which are our ground and one-way platform, but he's not assigned to a layer, so other things can't really detect him easily. So in order to keep this so that he's separate, we're going to specifically use layer 5 for our player. We're not going to put anything else on layer 5 in my game. And so if you like that method, go ahead and follow along. I'm going to go ahead and edit the layer names and come to layer 5. And I want to just call it player so that it's obvious to me when I'm looking for it. So now when I hover over that, it's the player layer. Hey, that rhymes, Mike. Okay, here we go. Now that we've got this area 2D detecting collisions or bodies on the player layer, it should detect the player when he enters. And likewise, because it's looking for collisions of other objects, but it's not putting itself on a layer, we don't need monitorable on. Because monitorable, if we look at this, it says, if true, other monitoring areas can detect this area, but if it's not on a layer, it can't. So that's pointless to have on. But monitoring, if it's true, this area detects bodies or areas that enter or exit it, right? So this is exactly what we want. Make sure it's monitoring. You can turn monitorable off, and then make sure he's got the mask configured so that he's detecting collisions on the same layer that your player exists on. Now, one last thing that we'll do is let's come to our collision shape here and just look at the rectangle. By default, it created this 20 pixel by 20 pixel box. I'm going to configure this so that it matches our levels grid. So let's go ahead and make it a 32 pixel by 32 pixel box, just like that. And then I'm also going to come in here and I'm just going to select this and I'm going to drag it up so that its bottom left corner is on the origin of my object. You can see that here, right? And we're going to do this for a very specific purpose. This is important for how we're going to code it. If you didn't do it this way, your code may differ a little bit. And if you don't account for the position of this, you might run into some bugginess when the player's transitioning. So this is fairly important. And just so you can see, because our box is 32 pixels wide and it's measured from the center out, we had to just offset it by 16 pixels to the right and 16 pixels up, or negative 16 pixels on the y-axis. Okay, so once you've got that set up, then you're ready to move along with me to the next step. Okay, now that we've got this set up, it's time for us to add a script to this level transition to control all of its functionality. So I'm just going to come up here, right click, attach a script, and yeah, the language gscript, blah, 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 blah. Let's go ahead and give it a name. Actually, I've got built-in script turned on. I don't want that. There we go. If we have that turned on, I don't know if I've covered this in the past. Built-in script means that the script is going to just be a part of this scene. It's going to be baked into the scene. All of the code's going to be in there. So it's not going to save it as a separate file. It's saved within that scene file. That's maybe handy if you have a script that you only need to use once and it's pretty basic. But I think this is not a great practice to use because it's nice to have the script in a folder where somebody else can come and look at it pretty easily without, you know, hunting around like, where is the script for that? I don't know. It's on some node somewhere. Okay, so what we're going to do is just, it'll save it in that path. It's going to call it level transition. We should be good to go once we turn that built-in script off. We'll go ahead and close these other scripts. We don't need those right now. So let's set up the script. A couple things. This script is going to be a tool script because just like our level bounds that we've built in the past, we want this script to run and execute in the editor so that we can preview the changes that we're making to it. Secondly, we want to give it a custom icon and custom class name. And then beyond that, we're going to build the functionality. Okay, so let's go ahead and get those basic setup things done first. We'll just make it a tool script, and then let's add the icon. And of course, this icon is optional. You don't have to do this. But in my general folder, I've got a level transition icon. Whoop, just like so. And then we'll give it a class name. Dang it. I hate that. I hate how the autocomplete gets rid of extend. Okay, class name. And then what are we going to call this? Level transition. I got a new keyboard and I'm having a hard time with it. And so in spite of my rough typing history, it's probably going to get worse for a while while I get used to this keyboard. Let me show it to you real quick. It's like, it's really tiny. And it's glowy. I mean, you know, they're all glowy. It's like a mechanical keyboard, but it's got nice, somewhat quiet keys, not too clacky. Okay. Going to go ahead and save this. Now, before I advance, because I've added this icon and it's not showing, I'm going to just restart my project, The Joys of Godot. I wonder if they'll ever make it so that this happens, but let me reload this and we'll be right back. And we're back. And of course, our level transition now has the nice little level transition icon, just like a green box with an arrow on it. Okay, and that green box kind of matches the color I'm using here. So you can see I'm trying to keep it consistent and have a color-coded visual language between our node types and how they look in the editor. But once we've got that, we're ready to start building out this script. So the way we're going to be building this is we're going to have it so that this level transition will trigger a transition to a new scene. So we need to be able to store a reference to what scene are we going to. And then we'll also be able to provide a name of the level transition that we want the player to spawn at. So if I come over here, let's just go ahead and actually add one of these level transitions to this scene here. Okay, so I've got my level transition all the way up here in the top right. It needs to be over here, right? And we're going to make it so we can configure the size so it'll be taller so that the player can't jump over it or whatever. But let me just go ahead and lay this out real quick, get it snap into the grid. Okay. Once we enter this, we're going to trigger a sequence of events, right? Because the player is going to enter the transition. And then what we need to do is a couple things. We need to load a new level scene, free the current level scene from memory, get rid of it so that we don't just end up with all of our levels stacking on top of each other. And then we have to also move the player to the new position, right? So if he's entering this level transition, and then over here, let's say we have another level transition, right? Let's go ahead and just add one right now. Wrong add. Okay, so we're going to have like a level transition over here, right? And I'm going to go ahead and stick it here for now. We're going to have to move it. Okay, so we need it to know that it comes through here. But doing that communication between two scenes as we're loading and unloading is difficult without the help of a third party and a third system. And so what we're going to do is we're going to also create what we'll call a scene manager. And the scene manager is going to be the one that's actually responsible for the loading and the clearing of the scenes, as well as any transition animations that we want to add. And then it's going to have signals that it will fire out throughout this process so that the other nodes in our game can respond to it if they need to, right? And the one node that is definitely going to need to respond to those is going to be our level transition. So let's start though by just finishing out some of our level transition, and then we're going to pretty quickly get to a point where we're going to want that scene manager as well. And so we'll get there. But first, let's start with the variables that we need to export and be able to manipulate with our scene transition to be able to handle this. A couple things that we've clearly mentioned, right? We want to be able to configure the size of this. So let's go ahead and create an export variable for that. And actually, I'm going to make this a range. So export range. For each of these, because I'm going off of like a 32 pixel grid, I want to keep that relationship and that sizing paradigm, I guess. And so I'm going to have a range. I think the minimum size for any of our entrances should be two tiles tall. Okay, so this is an integer, and I'm not talking about pixel height. I'm talking about grid height or tile grid. So 2 tiles tall would be the minimum. The maximum, I don't really know. We can put, let me put 16 in there. I don't know that we would ever get that high. The step is going to be 1. And then I'm going to add one other thing in here, and I'm going to say or greater. So if for some reason, in fact, I'm going to limit this down to 12. What this or greater string tells it is like, yeah, we've given it a range of 2 to 12, but if the user manually inputs something larger than 12, then just go ahead and accept it. Okay. Our variable name for this will be, we could call it height, but technically this is going to rotate when it's on a side. So we'll just call it the size. And then of course, this is of type integer, and we'll set it to our minimum value by default. Okay, so this is the first variable that we need to export. Now, in addition to that size, which now you can see the size here, right? We're going to make it so that this updates the visual size and the size of our collider. But we also need to have some way to reference which side of the map this is on. Like, is it on the right or the left, or is it on the top or bottom, right? So we've got 4 options there. So let's make an export variable for that as well. We're going to use an enum for this. And we've used enumerables maybe just a little bit, but these are just essentially a special variable type that lets us reference it by name. This is safer than doing a string where you type left, right, up, or down, because then it's not prone to typos. If you want to use a string for this, I'm not going to complain with you, but we might as well try something that's newer and learn from it. So we can call this enum the side. This becomes essentially like a new variable type that we can define, and the options for side are what we're going to list within these brackets here. So we're going to have left, right, up, and down, just like that. Actually, I don't want up and down. I think I want top and bottom. Same difference, just different language, right? You'll notice that as I define this enum, I'm using all caps. That's kind of a standard practice with Godot and GDScript and many other languages. I'm going to go ahead and put this enum here at the top of my class, since I'm going to define that before I need it. Now we're going to export another variable here. We'll say export. And in this case, we're just going to say var. And this variable, I'm going to call the location. You could call it side with lowercase, but I think location is good. And this is of type side. Okay, so you can see I got a type. It highlights it green because it recognizes this part of our script up here. And we can set it to a default variable. So let's just set it to equal to side.left. And you'll notice that we assign it by doing this. We use that name again, the enum name, and then we do a dot, and then we essentially assign the variant you know, which of these enumerables is it equal to? And so we're going to pick left. I'm going to go ahead and save this. Now what's cool is when we look at our level transition, you can see, I'm going to go ahead and refresh these in here and save them. By the way, I'm on my level transition right now because we didn't add these scripts, so I want to save these defaults. So now we've got location, and there's a nice drop down where we can pick. And you can see that even though I typed them in all caps, it still converts them to like a nice title case, so it's easy to read. But now we can pick one of these, and it's not a string, it's like an actual hard-coded value. And what's kind of neat about that is when we're typing our code, if I misspell left, oh, look at that. It helped autocorrect for me. It's like, oh yeah, do you mean left? Because L-E-F-T is not a, lowercase f-t is not valid. But if you want all caps left, you can do that, right? So this forces you to be able to make sure that you enter it properly, right? Because if you had misspelled left in a string, Godot is not going to tell you there's an error there because it's not doing a spell check. And it doesn't know if you intend to spell something wrong or right. I mean, this though will. You saw that when we had it misspelled, it's going to give us an error. It's going to say, hey, can't find lefer in level transition.side. Can't find that. Not a real value, bud. So there we go. That was a weird explanation. I wonder if that helps you understand the benefit of using enumerable type variables. But there we go. We've got two now. We've got our size and our location. We just need maybe two more export variables now. Because what we need is we need to know, okay, which level am I connecting to? Like when I enter this, what level do I need to load? And which area or level transition am I connecting to within that level, right? And we're just going to use the name. So this is by default called level transition because that's the name that we gave that scene. I'm going to come over here to scene 2. We're going to be connecting to scene 2 and to this level transition node. But the reason we want to provide a name is, let's say we have two. You notice when I duplicate this, the second level transition is now called level transition 2. Okay, and I can move this around. So we're going to put this one down here because that's where it's going to go eventually, right? It's going to be the downward transition. But we'll use this unique name to tell the other transition, like which one am I spawning at, right? And so obviously when we're going from this scene 1 through this level transition to scene 2, this level transition is the one we want to enter. You could give it any name you want at this point. You just have to make sure that you type that name in when we connect them. So let's go ahead and set up that part of the script. We'll set up those export variables. So we're going to export. Now in this case for the scene, we can export a file like this. And inside here, you see how there's a filter option? We just make some quotes and we type a string, and you can filter by types of files. What we're going to do is we're going to add a star dot, and then we're going to do tscn. That's the extension for a Godot scene. So what this is telling Godot is like, hey, we want a file, but it has to be with this extension. We're only going to let them put in a scene file. Okay. And then we can go ahead and give this variable, this export variable, a name now. So we'll just call it maybe level. We'll call it target level, actually. I think that's better than just level. You know, this is technically going to be of type string, and we'll by default set it equal to an empty string. And then let's go ahead and export another variable. And this is the target area, the area that we want to, you know, which level transition do we want to spawn at? So we'll just call it target area. I don't know, maybe target area name is good. And if you want to make it shorter, you can, the variable name that is. This is also a string. And by default, I'm going to set this to level transition because as we can see, that's basically the name of all of these. We might just have to add a number or something after it unless you rename them. But now that I've added these and saved it, now when I select these level transitions, you can see that we've got a target level and a target area. I'm going to come in here to my level transition. I'm just going to reset these so that those are the defaults and save it. Then when I come back, these level transitions that I've added will reflect those defaults because we haven't altered them. Now for the target level, let's go ahead with this level 1. And let's target, you notice we can click on that actually. I mean, there's a couple ways we can do this. So with this first level 1 to 2, let's say we're going to find a level, and then we can just come in here and go into our levels folder, forest, and get scene 2. That's one way we can do it. And you can see now it puts a reference to this, and it's got a path. You can show either the scene path or you can show the scene UID. Either way, the default was path. I'm just going to leave it as path. Now, alternatively, like for scene 2, we're going to take this transition and it also will transition, but we could find the scene that we want to transition to and just drag and drop it on there, and that will work just as well. And of course, for both of these, we're just transitioning to the level transition target area. So we don't need to change that value just yet. Now for level transition 2, maybe perhaps we do want to set this one up. This one is going to transition to scene 3, and it's going to transition just to the level transition as well, I think. We'll go ahead and save that. Let's come over here to this scene 3. Let me add a level transition, and this one can be at the top. Turn on my grid so it snaps. And this one will transition back up to level 2. See, you could just drag and drop the whole level in there. Level 2. Oops. I lost my level transition. Here we go. Level 2. And this one is transitioning to level transition 2. Right? Because we want it to spawn at this guy right here. Level transition 2. Okay. Okay. The next bit of code that we're going to do on the level transition script is going to have to deal with the tool in editor effects that we want. And we want to be able to change like this location, like to right, or in this case, bottom, and we want it to reflect where that's going to transition. And we also want to be able to change the size and have that update the size of this collision shape. Okay. So let's go ahead and hop back in here to our level transition. We're going to use a setter function on both of these so that we can achieve the desired effect. And we'll start with the size. This is a pretty simple. And we're just going to go ahead and add a colon after this. And sometimes you can say set equals and then give like a function name that you want to run. I'm going to do something a little bit different on this one. We're still going to use that basic syntax, but I'm going to go ahead and go down to the next line, make sure it's indented, which it should do automatically. And then we're going to just define kind of like an inline or a lambda function. So we're going to say set value and then a colon. And now we can just define a real basic function here. So what we want is we want our size to equal the value, right? I mean, that's the obvious thing. Otherwise, it's not going to update the size. And then next, on the next line, we're going to call a new function that we need to create. And we're going to call this apply area settings. Okay, just a simple function like this. I'm going to go ahead and copy this. And looks like I zoomed in a tiny bit. Let's go ahead and create this new function down here. And we'll fill out this function in just a little bit. The reason we're going to do it this way is because I want to do basically the same thing with our location. When we change our location, I want to update the value, but then I want to do this same apply area settings function. And obviously we can't assign the size or the location through this function if we were to, use this as the setter function. Okay, so this is just kind of a different way to use setters. So I'm going to do the same thing here. Set the value, and then I want, in this case, the location will equal the new value. And then we'll just go ahead and I'm going to copy and paste that, apply area settings, just like that. Okay, so now both of these are going to run that. They should still both work just fine. So if I go back here and look at my level, I can still change these, right? I can, and they still update. They just don't update this collision shape just yet. So now that's going to happen within the apply area settings. So apply area needs to look and say, okay, we've updated our area. Let's adjust the size and maybe the location of it so that it reflects the proper values. Now, in order to do this, let's go ahead, looking at our level transition scene, we want a reference to our area 2D. So I'm just going to go ahead and grab this, hold control, and drop it in there. Okay, so we've got our area 2D, right? And so now we can make the changes or manipulations to this through code that we need to. So we can come down here now to apply area settings and do those changes. I'm going to go ahead and do this because this is a tool script. This is going to be running while we are in the editor. And sometimes, even though we're getting a reference to our area 2D, sometimes this might try and run before this onReady variable is ready. Okay. And so I'm going to go ahead and add some conditions in here and some extra code to make sure that this kind of works. First, I'm going to say area equals, and we're going to try and assign the area through code. Okay, so that if this, or area 2D, I should say. So that if this isn't ready, then maybe the script will catch it. Now we can say get node, and I'm going to use this get node or null so that we can check against it. So what we're going to do is we're just going to give it the node path, and it's just the area 2D name, right? And in fact, yeah, hold on. That wasn't the right thing. You could see it. It was auto hinting to us that, is this the one you're looking for? So let's just peek at this function real quick. Get node or null fetches a node by node path, which is a string, similar to get node, but does not generate an error if path does not point to a valid node. Okay, so just because we might have an invalid node for some reason, this is a safer way to handle the code. And I'm going to add one more check, and we're just going to say if not area, meaning, hey, did you not get an area? Then let's just return. Like, forget it. If we don't have an area, then we can't do that. I keep just wanting to call it area, but it's area 2D. There we go. Okay, so if there's no area 2D, then forget it. We're done. What we could do here is let's just go ahead and assume that we're just simply setting the area size. And I'm going to start with this, and we're going to have to manipulate this a little bit because we need to not only set the size, but we need to size it and position it a little bit differently based on this location. And we're going to do it with some simple math. So here's what I'm going to do. I'm going to say area.scale.y equals size. Okay, so we're going to scale the y. I'm doing it again. area2d.scale.y equals size. If I save this, and let's go ahead and do this on level 1. If I select this level transition and I increase the size, there we go. You can see that it's now sizing this based on the value. So minimum size of 2. So it's 2 grid values large, right? I mean, this grid kind of shows it. As we increase it, it just continues to grow by basically a tile size. Okay? Pretty simple. Now, what if we wanted this, however, to be on the right or the bottom? So like when we look at this level transition, this looks okay, except this is located on the left. And we want our origin actually to butt up and be the spot where our player first interacts. That's going to be important for calculating where the player needs to appear when they enter the next level. And so I'm going to drag this over. And obviously this size is working okay, but we want things to be flipped a little bit differently, right? If it's on the right, then this should be over. It should be start here and go to the left. And likewise, when we look at our level transition going down, we don't want it to grow tall. We want it to grow across. And likewise, if it's up or down, this box needs to be either above or below. In the case of this, if it's located on the bottom, then we want this to be below that little origin point, okay? So then we could drag the origin right to the edge of the map, and then theoretically this green box would draw over this area. So how are we going to achieve this? Let's go back into our script, and we'll just make some modifications in here. So what we need to do is we need to have a couple conditions so that we do our math and our scaling differently based on the location that they've selected here in the inspector. So first we'll say if location is equal to side.left, just like that, or if it's on the right. Let's grab both of these conditions. And I'm going to go ahead and do this, scale it on the Y, right? Because that makes sense. Like if we're on the left or the right, then we're going to be growing that upwards. Okay. Let's just look at it here. So we still, like this one, we still want it to go up. But in order to get the flip, here's what we're going to do. We'll go right down here, and then we'll just scale it on the X-axis to either 1 or -1. So we'll say if location equals side left, that needs a colon, then what we'll do is we'll get our area 2D dot scale dot X equals, now if it's on the left, it should be -1. Otherwise, we'll just say else, maybe, because if it's not the left side, then we know it's the right side because we've already verified it's one of these two. So if not, then we'll just copy this little bit of code, but instead of -1, it's just a +1. Okay, now if I save this and go back to 2D, now if I look at this transition, that level transition 2 here. Okay, now as I resize it, you can see it put it on the proper side because it's located on the left. So this thing will be to the left of the origin. If I set it to the right, it will be to the right of the origin. And of course, now we can change the height. Works pretty good for the left and right so far. And obviously we haven't put any conditional branches in for top or bottom. So, you know, we could come look at this guy. Now that had location left, it should be location right. And then let's just make it big. I feel like it should be at least as tall as our level, if not taller. And because we don't have a top on here, I'm going to just go ahead and make this really big, like 20. That way, I don't know. Hopefully the player can't jump that high. So we'll just set that to 20. I'm going to go ahead and save that. I'm going to come over here. I'm going to set this one to 20 as well. I think that's a little bit ridiculous, but we can do it. So why the heck not? There we go. So now we just need to make these other transitions work for the bottom here and for the top here. Okay, so let's look back at the script. So if it's one of those locations, do this, but if it's not, we'll just say else. Then we know that it's either top or bottom. And so now instead of scaling the area on the Y by the size, I'm gonna go ahead and copy that. We're now gonna scale it on the X by the size. Okay, save that. And then we'll do a similar check here. Okay, I'm gonna go ahead and copy this because it's mostly the same. So we can say if this is on the top, then we want the Y scale to be, I guess in this case, top would be 1. And then if not, that means it's on the bottom, then it should be -1. And this, I need to change this to Y as well. Okay, so you can see we're kind of flipping. If it's left or right, we're scaling it on the Y by the size, and then we're making the X scale 1 or -1. If it's on the top or bottom, we're scaling the X size by the size, the X scale by the size, and the Y by 1 or -1. So if I go ahead and save this, now this should work. If I go back here, and let's adjust this. Well, it's set to left. Let's set it to top. There we go. We can see it's above the origin, and I can increase the size. 3 grid tiles wide is perfect. Fills that just right. And if I go back to scene 2, and I grab my level transition 2 here, let's go ahead and click it onto the bottom, and there we go. Now we can see that this works just perfectly. So now we can go through, and when we add these, we've just got a couple of things that we need to set to configure it so that it's ready to work. And of course, these don't do anything yet, right? But they do stuff in the editor, but they don't do anything in the game. So if we were to run our game right here, we can run into that green thing. We're still just going to fall out of the level. And we're just gone. Now we're gone. Gone forever. Lost into the gray void. I wonder if the gray void would be a good name for the game. Beyond the gray void. Okay, so there we go. Make sure that you've got your level transitions set up like I've got mine. And then next we're going to start making them so that they actually transition levels. Okay, I'm looking here at the level transitions script. I'm going to go ahead and create my ready function as we get ready to start building the functionality here. So we'll use obviously the built-in ready. And we don't want any of this code to run in the editor. Everything that we're going to do pretty much from this point forward is going to run exclusively when we're playing the game. So because we're going to initialize a lot of how this scene works in the ready function, or stemming from this, I'll just add that handy dandy if engine is editor hint. So if that's true, then we're going to return, because we do not want to run any of this code. Now let's begin by doing the following. When we look at our level transition scene, this area 2D is what's going to be doing the detecting, right? And so in our script, what we need to do is we need to say area 2D, and here we're going to have a body entered signal. So body entered is what's going to fire when the player enters this area. Okay, so we want to connect to that signal. And then we're going to call a function. We'll call it onPlayerEntered. I know some of you are probably wondering, like, how can you be sure that the player entered? And again, this is because of the specific way that I've configured my game and my layers. So this is only detecting on the player layer, mask of layer 5. And my player is the only game object in my entire game that exists on that layer. Now, if you didn't do that, you could just say on body entered, and then you could just do a check within your on body entered function to see if it's the player, right? And if it's the player, then you could do the same thing. But that's the only difference in how you might write the script otherwise. But I just like the simplicity of this. It's kind of set and forget, I guess, but whatever. It works for me. So I'm going to go ahead and create this on player entered function here. Now, because we're connecting to this, it is going to pass us, if you look at body entered, you can see there in the signal, it provides the node 2D body. So I'm going to go ahead and give it an _n, and it's of type node 2D, because I'm not going to actually reference that right now. Okay, and then let's just go ahead and put a pass on there so we can end that function. And really what we need to do when the player enters it, we need to transition to the attached level, right? Sounds pretty simple and straightforward. And actually, it's not that hard. We could kind of fake it real quick. Let's go ahead and just do some debugging. We can like print player entered, player. Yeah, let's spell it like that. I think we should all spell it. And entered. Oh my gosh. Welcome to the magical world of Michael Games. or everything's spelled incorrectly. Okay, player entered. We can just test this real quick. We should see that message pop up in our console when we run out of the level here. Player entered. Okay, it's working, but obviously that's not what we want to do. Now there's a really simple function that we can use to just load the new scene, but you're going to see that as simple as this function is, we need to do a little bit more. Otherwise our game's going to be kind of goofy. And the simplest function we can use in place of this is going to be the get tree, okay, which is going to get the root node of our game scene tree. And then there's a nice handy dandy function that's called change scene to file. And so what that does is it's going to say, okay, let's take our root scene and let's dump it and replace it with this other scene. Okay. And so you can see here, we've got all these, it actually recognizes some of the scenes in our game, right? But we want to actually use the one that we've referenced because we did provide that export variable, right? Target level. So let's just go ahead and pop that in there. Change scene to file, target level. Okay. Get ready for this. Ready? Can he do it? Haha, it worked. Except where's our player? And what's happening? Right? Like what's going on? It's not working at all. And that's because our player, if we look at this, when our player left scene 1, if we look at where the origin is, he's like clear over here somewhere and he's falling. And then if we look at scene 2, here's that origin, that same distance, this level's roughly the same size. So the player was probably right here and just fell straight down. Let's test this. Let's see if I can jump in and then back and see if I can come back. Ready? Oh, I'm holding left. Maybe we'll pop out. We're going to pop out. We're going to pop out. Where we go? He's gone. He's gone forever. Actually, you know what happened is even worse? Pretty sure our player got deleted. Let's look at this debugger error. Removing collision object during no physics call, blah, 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 blah. Okay. We removed something that we probably shouldn't have during this physics callback. You see how we're just running into errors. I mean, okay, we've got a couple things going on. Some of them are going to be harder to debug. Possible solutions. One, when you free a level, you need to make sure you add a new player. You know, so like, for example, let's put a player into this scene here. And, oops. Well, I guess that was right. Okay, let's put this player down here. And when I run the game again, hopefully we should still have a player now. Okay, cool. We've got a player. But I don't like doing that. Now, many games will do this. They'll just load a player with every scene. You still have to deal with positioning him, right? Because what if we had entered from down here? You don't want, or from the right edge of the scene. We don't want the player to be all the way on the left side, right? So, okay, we'd have to deal with that, but that kind of works. Also, because I'm not a fan of destroying and loading the player and having to kind of keep his state in sync. And maybe that's just me being lazy and maybe it's bad practice. I don't know. If you guys have a differing opinion, let me know. But my preference is I'd like to keep the player. I'd like to keep him as a part of the game and then just move him. Just move him to the new level. I don't want to create a new player. I don't want to have a player on every scene. I just want one player for the whole game. And to be honest, that's going to be a little bit problematic at this moment, and we're going to refine that a little bit with that player spawner node that we'll make later in this chapter, but we can work around it in the meantime. But I just want this scene manager instead to handle this. So what that means is, looking at this code, I don't want to handle this scene transition here within this, because as soon as this signal gets called, and by the way, this debugger error is because we're doing something that's going to queue free a level. It's going to get rid of a level. It's removing a level, but it's in a deferred signal responding function, and it doesn't like that. It's problematic, okay? So we're going to remove that from here. We're going to put this in the scene manager. It's going to clean this up. So now the level transition can focus on other things that it needs to do, and we'll offload handling, loading new scene, freeing the old scene, etc. to this new global script. So let's go ahead now and let's create that script. Okay, new script time. Now this new script is going to be special. We're not going to be placing this script on a node in our scene manually like we've kind of done so far. What we're going to be creating is an autoload or a global script. Many of you are familiar with this concept. If not, don't worry, it's going to be pretty straightforward. So I like to personally, in the root of my project, create a new folder, and I call it 00_global. This 00 underscore ensures that it's going to be at the top of my list. And then I'm going to put all of the scripts and things that I need to be globally loaded within this. So I'm going to create a new script here. Actually, I take that back. We're going to make a whole new scene because I could just create a script, right? But we're going to want to add these visual transitions here. So we'll want our scene to just be there. So let's go ahead and do this. Let's create yet another folder and we'll call it SceneManager. Okay. Now, within the SceneManager, I'll create a new scene by the same name. And I'm going to make this, I don't know, I'll make it a user interface node for now. Okay. And then let's go ahead and open SceneManager. And actually, I guess I don't want this to be a control node. I'm going to change the type. I'm going to make it a canvas layer. There we go. Yeah, canvas layer. You can see this is a node used for independent rendering of objects within a 2D scene. And this means it's just going to kind of render on top of our game. Okay. And then we can add control nodes as a child of this. But we're going to add this SceneManager node like this. I'm going to go ahead and save it. And then I'm going to come in here. Let's make it obvious. So for now, let's just, we're not going to keep this, but just as an example, I want to add, I'm going to add a control node. And then I'm going to add a label to that control node. And in the label, I'm just going to put test. Okay, so this label is in the top left of my SceneManager scene. And then if I go up to project settings, you can see there's a tab for globals. And make sure you're on the autoload. There's shaders and other things, but autoload is what we want. And we're going to look for this scene. You can autoload a script or a scene, okay? So I'm going to go ahead and, in this case, we're going to load the scene. And you can see it gives it a name, SceneManager. And I think that's great. Once you are happy with that, click Add. It'll add it to this list below. Now what it means is as soon as my project runs, Godot's going to load this SceneManager, bloop, and it's just going to be there. It's always going to be running with my game, unless somehow I remove it, right? You can see it's a global variable, which means I can access it by the name we've assigned here. I'm going to go ahead and close that and save it. We'll look at this a little bit further, but for now, let's just run our game and test it. You can see it says test up there. So even though I've never added this scene anywhere, it's there. In fact, if I run just scene 2, right, there it is, test. I can go to scene 3 and I can run it with F6 and it's going to say test. Okay, so you can see how that node, that scene that we've created is just going to be loaded with our game. Okay, cool. First step done. We do need a script on this SceneManager, so I'm going to go ahead and right click, attach a script. SceneManager is great. It inherits canvas layer. Wonderful. Now, normally I would give it a class name. With a global script, we can't give it a class name because that will conflict with the name that we've given it in our project settings. So for these global scripts, we don't give one. Essentially, the class name is just assigned here, right? You can consider it to be basically the same thing. But now we've got a script attached to our SceneManager that we can leverage. And let's just go ahead and make a fun little test function. So I'll say function test. And we're just going to print test to the console or to the output. Okay, so now what we can do, let's take our level transition here. I'm going to remove this. We don't need that right now. Let's go to our SceneManager. You see how I can type that and it even recognizes it? SceneManager dot. And now we can see it hasn't quite saved yet to know that we've got a test function. Eventually this will pop up, but we can call test. Okay, so now when we enter a level transition, we should print test out in our output down here. Let's go ahead and run our game and test out my theory. Oops, didn't want to do that. Oh my gosh, what are you doing? What are you doing, Mike? Okay, nothing in here except that. Whee, test. Okay, cool. So you can see now that any script in our game can call the SceneManager and access its functions and methods. Okay, so this is going to make it really handy to use. We're going to use this to do our level loading and stuff like that. I'm going to delete that for now because what we want are some real functions that do real things, right? So let's come into our SceneManager and let's replace this. What we want, let's start with a function actually, a real function. And the function that we want is going to be to transition a scene. So let's just call it that, transition scene. Now we can just make this return void Okay. What does transition scene need to do? The basics that it needs to do is just that one line of code, right? We had that one line of code. I'm going to just put it right here. Get tree dot change scene to file. And then we passed in a name. We don't have a name, so we need to make that an argument of this transition scene function maybe, right? So we can pass it in. So we'll say new scene, whoop, which is a string. And now we can just come in here and put new scene. So if we were to go here to our level transition and call SceneManager dot, I really wish it was picking up my functions already, but it's not. Dot what is it? Transition scene? Let me just copy that because I'm lazy and dumb. Transition scene, and obviously we need to provide, what did we call it here? What did we call it here? Target level. Guess we could call it target scene or something, but whatever. Okay, target level. So now this should work again like we had. It's still going to be buggy, but we've offloaded the handling of that scene transition to our global script here. Okay. But here's what we need to do. We need to add more to this so that it's more robust and it can handle things before and after the scene loads. And so what do we need? We need, in addition to the scene we're loading, we want to know what's the target area, which is also a string. Okay, so this global script is going to help us remember because right once we leave this transition area, we want it to spawn at a target area name. But how are we going to remember it once this scene is gone, right? So, okay, let's pass that in there. Now we can pass in our target area name. What else do we need? We also need to know two other things that we're going to use for the future. We're going to have an offset for our player. I'm going to call this the player offset, which is a vector 2. This is going to help us know where to position the player. And we're also going to want a direction. I'm just going to call it dir. And this is going to be, in this case, it's going to be a string as well. Okay. Now we've got all this stuff that we're passing in that we can work with. And since this is global, again, even once we clear the scene that loaded or called the function, it's going to be retained in memory. Of course, here in our onPlayerEntered, we need to now provide those. So transition scene, it still hasn't figured out my global script here. But so let's just go reference it. We need player offset, which is a vector 2, and we need a direction. Okay, let's just pass in some fake values here for now. We'll replace these with real ones. So I'm going to put a vector 2.0, and I'm just going to put left. We'll just pretend. It's going to be something like that, right? Okay. This isn't any different yet, though, because it still does the exact same thing. But now we've got reference to all the data that we're going to need to make this function work. Now, one other thing that this SceneManager is going to do is it's going to emit signals. I think I already mentioned that, right? But we want some signals so that the game can respond to them as needed. And what's nice about signals is we can create a signal on our global here, and it'll emit them. It doesn't care who is connected to those signals, or if nobody's connected to them, it's still going to emit the signal. And all it knows is, hey, I'm just responsible for telling the game when these things happen. And then any node that needs to, any script that we write that needs to respond to the signal can do so. And there's no knowledge of each other. They just kind of work. So the first signal that we're going to have is when our load scene starts. So we'll call it load scene started. And then I'm going to have one for load scene finished. Okay. And we're going to have actually another signal. I'm going to put it right here in the middle of these. I'm kind of listing these in order that they happen actually. So first we start loading our scene, and you're probably thinking, why are we having so many steps? Trust me. New scene ready. And I gave this one parentheses because here, when the new scene is ready, what we want is we want to not only emit the signal, what we're going to use this for is we're going to say, okay, once that new scene is loaded and we're ready to plop our player into it, then we're going to fire this signal. Okay. And we're going to say, okay, here's the target name, meaning this is where the player needs to spawn. He came in at this entrance, and here's his offset. Okay. So these values here, the target area and the player offset, they're essentially just going to be held onto and emitted when we emit this new scene ready signal. Otherwise, these signals are going to be just general utility. So things know, oh, hold on, we're loading a scene. Oh, okay, when it's finished, okay, we're good to resume, right? Something like that. So what we can do is we can come here and we could say like before we do this, we could say load scene started dot emit. And then right around here, we want to emit a signal that the new scene is ready. So we could say new scene ready dot emit. And now, of course, this is expecting us to pass those arguments, right? So we're going to have our target area and our player offset like that. But technically, before we emit this, we kind of want to wait. And what we want is this function is not going to just run in one tick of the game. It's going to be an asynchronous function, okay? So what we're going to do is right in between this, we're going to make an await. There is a special signal here in our scene root. So we can go getTree.scene changed. And when this signal happens, we'll know that this function has completed its work, right? So that might take, it's probably just going to take one process frame or something like that. I don't know. Maybe it could potentially take longer. But this way now we know that, okay, we'll change the scene, but we're not going to say that it's ready until after this signal has been fired by the game, by the, by the scene root. And then that's essentially when we're done. But eventually down here, we're going to emit one more signal, right? That's our load scene finished. And at this point, it might not be clear why we have a couple of waits, because theoretically we could probably just get away with just this one, right? The reason why we're not going to do that is because we are also going to be building in that scene transition, the fade effect. And so since that can take some time and we want to make sure that we don't mess up because we're waiting for that to happen or something, we're going to play back some animations throughout this. Okay, so by having it broken into the 3 steps, we'll know when it started, okay, screen is fading out. And then once the screen is faded out, we'll load the new level. And then we'll wait for it to be loaded. And then we'll tell the game, okay, new level's loaded. Go ahead and plop the player in. But we still need to fade the game scene back. And so let me go ahead and just make some comments for that, right? So we've got fade new scene in. Here we're going to fade new scene out. And then the rest of the stuff is kind of already here, right? More or less. But that's why we've got these extra little pauses. Okay? But this load scene finished, that is definitely the last thing that's going to happen in this script. And, this load scene started one of the first ones. Now that we've gotten this far, let's go over to our level scene transition and let's kind of start working with this scene manager in a couple ways. So we're already connecting here to our onPlayer entered, or, to the body entered signal, I should say. But really I want to do a couple things. So first I want to say SceneManager, and let's get the new scene ready. New scene ready.connect. We're going to connect this signal and we'll say on new scene ready, or yeah, that's fine. And then let's make this function. This apply area settings, I'm just going to keep pushing it down and down and down. And as we recall, right, in our SceneManager, this new scene ready, it emits these bits of data. So I'm going to go ahead and copy that, come over here, and just put them in there in my function signature, so we know that these are the arguments that we're getting. And then what we'll do here is I'm going to make a comment, position player, okay? Likewise, we're going to connect to one other scene manager signal here. So we've got the load scene finished. So let's grab and connect to that one. Man, none of these are auto-completing for me. I wonder why. Let me comment this out. Just run the project real quick. See if that helps. Okay, load, scene. It's not doing anything. Got connect. So I hope I'm spelling all of this correctly. So we'll make a new function here for this as well. On load scene finished. And what we're going to do on this on load scene finished, so we've got some stuff that we have to be careful with. One of those is this connecting to the body entered. We don't actually want to do this as soon as this scene is ready. We'll do it once this load scene is finished. Okay. The reason we're going to be doing that is because we don't want to run into a scenario where we can actually trigger like multiple level transitions. And let me show you a weird example of this real quick. Okay, in this little demo version, let me turn off the grid here on a couple of these. You can see I've got some levels set up Let me put them in order here. Okay, so I've got like level 10, level 11, and level 12. And notice that they're all the same size. And so what this means is like level 10 and level 11, they have a level transition in an identical transform. You see that? It is on the X, 480 pixels on the X axis and 192 on the Y. Right? If I select this one, same, exact same thing. And likewise on the left, if I look at the transform of this, it's going to match up with this guy's transform here. Okay, 0, 192. What that means is if we're not careful, we'll get this following scenario. You can see here I'm on scene 10. Now watch as I go into scene 11. Boom, boom. It just like instantly loaded me into 12. But I have my scene transitions already hooked up here, and you can see that we did the 2 fades. But essentially what's happening is we're going from scene 10 to scene 11, and then this area is getting hooked up and ready to go. And before the player has even moved to his new location, because he's a collision object that happens on the physics frame, which is like a different system, he's already registered that he's been entered into this guy here, right? Okay, so player enters here, scene loads, he enters here, scene loads, and then finally it's like, oh, okay, good. Nothing here to change, okay? Because we need the player to be repositioned to right in front of this. So this is a kind of a scenario that will arise, especially if you have a situation like this where our scenes share the same size and the locations of the transitions might be the same. Okay, so coming back to our project that we're working on, for that reason, we're going to be very careful and intentional about when we connect to signals and how we set this up, okay? Otherwise, you're going to have bugs like we just saw. Okay, so when the scene has finished loading, we'll connect this signal here, right, that we had before. We're basically going to set up this level transition script. And in fact, we're going to have to come in here and we're going to have to be extra careful as well. We'll be revisiting this function later. But what we've done is we've separated some of our functionality out, and we're going to run it depending on the signals coming from the SceneManager. Okay, so let's look actually at this on new scene ready, where we're going to position the player. Now we have to be slightly careful here because most of our levels in our game are going to have multiple area transitions. So we need only one of them to handle this. That's what we're going to use this target name for. So the first thing we'll do is on scene ready, our level's loaded, all of our stuff's in place, and each of these scenes, each of these level transition nodes is going to check. They're going to hear this signal that the scene is ready. That means they're all going to run this. If you've got 3 or 4 in one scene, they're all going to run the same code. So the first thing we'll do is we'll just check if target name, not target area name, we want this target name right there. So if target name equals name, because this node has a name, right? Level transition maybe. If those match, then we know that we are the intended area. And so then we can run some code. And then all of the other level transitions in this scene are going to go, oh, it's not me. It's not my turn. Oh, I'm sad. And then they're going to just not do anything because they're going to be lame and totally sad. Okay, so here we go. Target if the name matches, then we want to just get our player. And this is where I want to introduce how to use node groups. I know we've been doing things like, I specifically avoided a group, but here we are on our player. We need an easy way to grab our player. So when we select this, open your player scene, select the player, come over to node, and there's signals and groups. We're going to go to groups. And what we want is we want a group. We want to assign him to a group that we're going to call player. So I'm just going to go ahead and say add new group. We'll call it player. And this is a global group, meaning this is a group that is project-wide as opposed to just within this scene. Okay. You could give it a description. I think the name is description enough for this one. So I'm going to say, okay, there we go. So now this player node is part of this player group. Easy peasy. And if you're curious, I mean, yeah, that's cool. You can copy it to the clipboard. If you go into the project settings, under globals, we're already there because we were here. There are groups, and you can add groups as you see fit. These are the global groups, the groups that are accessible throughout all of our code. Okay, so now the player is on a specific layer. He's also assigned to a specific group. We'll go back to our level transition script. We're going to go in here and grab the player, and we're going to do it like this. Player, I'm going to do this. I'm going to do colon equals, okay? Which means it's going to be strongly typed, but it's going to be strongly typed to whatever this function returns. So we're going to say get tree, and then we'll say dot get first node in group. There's a couple different functions we could use, but the group we're looking in is our player group. And we're saying get first node. Our player should be the only node in this group, but whatever, it's going to get the first one. And then it returns it. If we look at this function, you can see that it returns a node. That's why I didn't want to do of type player. So technically this is of type node, I guess, if we wanted to flesh that out, right? And then all we're going to do, we don't care if this is, of type player class. We know it should be, but all we're doing with this code is setting its position. So, it doesn't matter too much. We'll just say player dot global position equals, and then here we're just going to say, okay, this is where we are. Now we have to be careful because we don't want, looking at our level, like let's look at level 2. We don't want our player to be here on the green thing, or we will run into a bug. He'll just go right back to the level he came from, and then you'll get stuck in an infinite loop, probably. We want him to appear to the right of it. So we actually need to set the player position differently depending on the location of this level transition, okay? And then we're also going to have an offset, which we've accounted for in our script, but we haven't really calculated that yet, but we'll get there in just a little bit. And then really all we need to do here is just get our global position. And then we're going to say plus offset. Oh, this is where it gets kind of scary, right? And so for now, just to be safe, we're going to have to hard code a value in here until we properly do it. So where is it that we call? This is on player enter. This is where we call this. And we're providing an offset of vector2.0. Let's give it a different offset so that we know it'll work. So we'll just make a new vector2. Now looking at our player, this is where things get kind of hairy. So I hope you guys are following along okay. But if we look at our player, his collision shape has a radius of 8 pixels, which means he's, 16 pixels wide. He's a thick guy. And this radius is important. We need to make sure he's at least that amount away from wherever we level transition to, right? At least 8 pixels over. And it's not 16 because he's getting positioned on this line here. So it's just 8 either direction. But just to be safe, I'm going to go ahead and on the X, I'm going to put 16. We'll change this later. And then we'll just put 0 on the Y. Because obviously, when we come from the bottom up, this is going to be totally different. We're not going to be positioning him on a positive X. It's going to be like on a negative Y, right? We'll get there. But for now, we're just going to say, okay, put the offset for him should be 16 pixels on the X axis. Okay, so what happens? Let's follow this through mentally. We call the scene transition. We pass in these values. Here in scene transition, we get our player offset as well as the target area name. And then eventually we emit both of those values. So this is going to say level transition 2 or level transition. And this is going to say vector 2 with 16, 0. And then our other level transition is going to pick that up down here. And it's going to say, oh, yeah, this is me. That target name matches me. Let's go ahead and put the player at my location, but then let's bump him over 16 pixels to the right. Something like that, right? That's going to be this. This is going to be that vector 2. So let's go ahead and run our game. And we should be able to, oh no, do nothing. Let's see what's going on here. Anything going on there? Scene 1. Let's try this one more time. I'm not sure why it didn't do anything. Oh, I know why. I'm sorry, guys. I made this so complicated. I made it so complicated. I didn't mean to. I promise I didn't mean to. One thing is we moved this connection to the onload scene finished. Well, the first scene that we ever load isn't loaded by the SceneManager. So it never fires this signal. Okay, so let's just account for that real quick. We'll just come up here at the beginning of our SceneManager script, and we're going to just add a ready function. And then we can just emit that signal here, right? We can say load scene finished dot emit. And now all of our things are going to pick that up. But to be safe so that we know that all of our first level is loaded before we emit this, we're just going to say, we're just going to put an await here. So await get tree dot process frame, maybe something like that. So the ready function is just going to wait a frame. Did I do it like 2 spaces? Wait a frame and then emit the signal. Hopefully this will make this transition work. Woo! It worked, I guess. Except we ran into a little problem here. Look, it looks like we didn't get a player. I wonder why. let's take a peek at our player. Make sure that he's in this node group. He is in there. I'm assuming that's what's getting this. Is it saying that global position isn't valid on the player or on the level transition? Player is null. You can see it right down here. You see down here in the debugger, when you get a breakpoint like this, a little arrow, you're going to find that information down here. Okay, why did our player come back null, I wonder? Shoot, I'm not sure I know what's happening here. Okay, so for some reason, we've got that issue. It's not finding this player when we do this command here. Okay, I'm in here. We're running the game, and I've loaded my little remote version. You know, over here in the Scenes tab, you can, when you're running the game, you can switch to remote, and you can see what's running. We can see the level we've got loaded. You can see our SceneManager here, that global script. There's the scene root. That's what we're getting when we call get tree. Now, you see our players right here, and he's a child of level 1. This is where the problem is, by the way. He's a child of level 1. Some of you may know what I'm getting after right here, but watch what happens when we go to the next level. I'm going to go pull up my game. Okay, so we're here. Watch over here. I'm going to just walk off to the next level. Boink. Okay. Hey, look, level 1 is gone. Cool. And it loaded level 2. But wait, no player. No player underneath level 2. That's because player was underneath level 1. So this is what I was referring to earlier. We kind of have a weird, goofy situation happening here. Right? Because our player is a child of the level 1 scene, he's getting removed with level 1. That's what the problem is. So I'm going to just come down here, and I'm going to do this. We don't have to keep this necessarily, but in our ready function of our player script, I'm just going to see if I can move my player outside of level 1. I just want to put him in, make him a child of the root scene. Self.reparent. Let's see if I can do this. Self.reparent. The new node is going to be get tree .root. There we go. Okay, that works. Looks like it'll work. So now if I run this again, let's go to our remote. Did it do it? It didn't. Our player's still a child of... Oh, do we have an error? Okay, interesting. Let's stop it. Let's try this again. I think we need to call deferred. So we'll say self.call deferred. And then this get tree is now a string name. Well, no, it's not. I'm sorry, not the get tree. The method we want to call is now a string name. So the method we want is reparent. And then these are the arguments. Let's try this. Ta-da-da-da. Okay, you can see here in my remote, our level 1 is here, our player is here. It's a sibling of level 1. So now if we remove level 1, our player should stick around. I didn't even plan for this because I built all of these pieces of functionality separately. Every now and then I run into these hiccups I didn't anticipate. So now, oh, look at that. It's a miracle. Oh, except it's not working so good when we try and go back, right? What's happening? Oh, we've got a lot of players because scene 1 spawns a player. If we go back over here, how many players do we have? Holy moly. Don't worry. We'll be fixable. I'm going to go ahead and stop running the game. But the issue with him going over, there's a couple issues. But one is simply that we're hard coding that offset. And so, you know, looking at our script for our level transition, we've got this offset right here. It's being set to this value right here, right? And we don't want to do that. This is just not how we want to handle it. So we need to replace this now. Hopefully, as you're following along with me and you're watching us make these mistakes together, it helps educate you on, you know, at one, that it's normal to not have everything go super smoothly, and two, that this is just part of development. But let's figure out how we can make this offset something that's calculated based on, you know, whatever, the actual values that we need. And in order to do so, let's just come down here and let's just make a new function, because it could be a lot of code, right? We'll call it get offset. Now this get offset, we're going to need to pass in our player, which is going to be a node 2D. We don't need, what we need, at D, we need his position, so we need it to be a node 2D at least, right? And then this is going to return a vector 2. Okay, so this getOffset function is going to return a value of type vector 2. And right now I'm just going to tell it to return null until we get ready to actually return something. Well, it won't let me do that. Return vector 2, 0. Okay, so we're going to do getOffset. Let's go ahead and, before we code this up, let's just plug this in where it belongs. So here in our transition area, right here, just going to paste in getOffset, and our player is actually this node here, _n. So we can just replace this with _n. Okay, so that'll give us a value. Right now it's giving us a value of vector 2, 0. Let's go ahead and just do this. Let's define an offset. This is of type vector 2, and we'll set it equal to vector 2.0. Now we can return the offset. And now any changes we make to the offset throughout this function will get reflected in what we return. Now, secondly, I want to get our player position. So let's say player _POS, which is a vector 2, and that's going to equal player dot, and we want his global position. Okay, so we're going to get the global position of the player node that we pass in and just kind of reference it there. I mean, that's just a shorter way of typing that, so we don't have to type that over and over. Now, what's going to happen here is we need to calculate the offset differently depending on the entrance, right? I mean, if we go in to this, then we know our offset needs to be to the right, okay? Because it needs to appear over here. But if we walk through this transition on the left, right, then we know that the player needs to appear to the left of this one. And likewise, with top and bottoms, we need to transition differently here. I haven't even tested these yet because they're just not going to work well until we do some of this code. Once we do this code, we should be able to test these up and down transitions. And then this debugger stuff, we're going to have to deal with that later. But for now, let's just work with these. So back in here into our script, we'll do, remember that code we did? In fact, we can copy some of this, right? If location is left or right, then we're going to do one type of calculation. Otherwise, we're going to do a different one. We're going to add on to this, but first let's just get the general positioning correct. So we'll say if it's this first one, and we're gonna do more stuff here, by the way. That's why I'm lumping the left and right and doing this. Otherwise, you could just do if left, if right. Okay, so if we're entering from the left, then what we need to do is we need to have an X offset of, in this case, let's say it's -12. I think technically that should be equals -12. Okay, so if you're on the left, -12 offset, else the X offset is a +12. Okay. And then of course we're going to do a Y offset here before this, because the Y offset calculation will be the same for both left and right, but we'll do that. Let's get this first part done first that handles the directionality that's different. And then we'll do an else. So this next branch of code is going to be if we're transitioning from a, top or bottom transition. And in this case, let's just copy this, although it is going to be a little bit different. So if our location is on the top, then we're going to set the Y offset differently on these. Now for the top, it's going to be negative, but it doesn't need to be very big, because what is going to happen is we just need to offset, right? The origin of our player is right here. So technically 0 offset should be fine. It should be above that little level transition, right? If we look over here, if we just put him right there at 0, it'll be fine, but we'll just put him 2 pixels above just to be safe. Okay. But then, left and right there. But then when we're going from the top down, we've got this whole collision box here, which is 46 pixels tall. We need to account for that in our script. So we're going to come down here and I'm going to give that same 2 pixel grace. I'm going to call it 48 on the Y offset if we're going down. Okay, so far we've set up some code that's going to give us the correct offsets. And these ones are kind of fixed based on the direction. Let's go ahead and just test that real quick. So I should be able to go through here, and then if I go back, this is going to get weird. It's going to get weird. Boink. Okay. But that's working, right? We can go left and right and it doesn't crash. Now, if I go down here, hey, look at that. And I can go up. So just magically like that, I can go up. Now, here's a weird one. If I go to the right and jump down, he appears on the left. Nope, that's not good. Likewise, if I'm jumping as I transition here, I just appear kind of on the ground. That's also not very good, right? So let's account for that now. And then we'll clear up these, whatever's going on with these duplicate dudes. Okay, so that's this more stuff. So for the left and right, what we want to do is we want to look at our transition, and wherever our player's feet are in reference to that bottom point. So if he's jumping and he's like, 64 pixels in the air, then we want him to maintain that height above this one when he enters the new scene, right? So he's up here. And that's going to be pretty easy to calculate, but that's why we've grabbed a reference to our player's global position. So we're just going to say, in this case of the left and right, the offset dot y is going to equal the player position dot y, player underscore position, player underscore pos dot y. And then what we'll do is we're going to subtract. I'm going to put self in here. You don't need this, but it makes it more obvious what we're doing. Self, this node's global position dot y. Okay, so we're just going to get the difference between those. That's going to be the y offset. Okay. Now this code is almost identical over here for the top and bottom, but obviously instead of up and down, we're going left and right. So we'll change these values to x's and we should be good to go. So let's go ahead and run this again. Now if I'm jumping, oh nice, he stays up there. And likewise, if I'm over here on the right or in the middle, I stay there. Okay, see how nice and smooth that's working? Because we're just remembering the position and updating it accordingly. Now we've got a whole bunch of heroes appearing here, and it's giving us a bunch of errors. I'm thinking most of these errors are going to clear up pretty quickly. Let's just do this. Let's go into our player. And before we even do all of this, I'm going to come down here and I'm just going to say if get tree. I'm doing this on the fly, so wish me luck. And then we want to get nodes, or get node, get first node in group. And the group we're going to check is our player group. Okay, so this is going to return null if there are no players. Otherwise, it's going to return something. So what this is saying, if this is, in other words, if this doesn't find a player, it's going to return null and it's not going to do this branch of code. But if it does find a player, then we know one already exists. And then we can just go self.free. Let's just try this. See if that works. Oh, let's do queue free. Is that gonna, yes, queue free. Let's run that. I don't have a player. I don't have any player. Oh, you know what? This is interesting. It probably finds itself. Does not equal self. Let's try that. There we go. Okay, that works. So now if I transition, I should, it's not, it's gonna, you see, normally we would have another player appearing here, but now that new player's going, oh, there's already a player. This is kind of weird. This is kind of weird. We're going to end up removing this later when we get to the spawner, or we can once we build that. But for now, this will work. So we're not adding more players. Queue free is safer than free. The difference between queue free and free, unlike object free, in fact, it talks about it. Let's look at object free. Deletes the object from memory. Boom, it's just gone. Pre-existing references to the object become invalid, and any attempt to access them will result in a runtime error, which we were getting. And so what we can do is use queue free. Queues this node to be deleted at the end of the current frame. So you notice the difference there? One just deletes it. This one waits for the end of the frame. And then when deleted, all of its children will be deleted as well. Unlike object free, this node is not deleted instantly and can still be accessed before the deletion. Okay, so queue free is the safe way to do it. There are times when you can use free, but if you're getting an error, then just try queue free. I've used free before in the past, but I guess I shouldn't have tried. Let's go back here. We've managed to really refine how these transitions work and communicate with each other. They're offsetting really well. Now we just need to clean up this error, and then we're ready to add those fade transitions as well. Okay, so let's look at this error that we're getting. Every time we transition, we're getting a couple debugger errors. And if we look at them, it's saying that you're removing a collision object during a physics callback, and that's not allowed. And so we should use call deferred. There is another way around this, however, and that's happening in particular because of our SceneManager. So here in our SceneManager, where we call transition scene, we're doing two things. We're emitting a signal, and we're doing this change scene to file. And this is where we're getting the error right here, because this function removes the current scene from the scene tree. And it's got collision objects in it, so it's freeing all of those. And as it happens, this transition scene is getting called from, let's see, where are we at? Level transition. It's getting called from the, where is it? Body entered, right? So this is during physics calculation. It's a signal that's triggered during something that happens in the physics. And then it's saying, hey, sorry, we can't do that. There's a simple way we can actually fix this. And this is going to be needed anyways. I'm just going to say await, get tree, and then process frame. And you'll see once we add this and run it again, it's going to go away. Because now we're freeing it in a safe manner because we've waited a frame. Okay, so this is getting freed one tick after the signal fired. So we no longer get the error, right? Isn't that cool how seamlessly it goes back and forth between them? Pretty nice. Now, before we go any further though, I want to show you, remember how I showed you that bug where if we have two transition areas that have the exact same position, then we're going to run into an issue? Well, that can happen. And let me go ahead and show you two example scenes that do that with this project. Okay, so I've set up 3 scenes here. I've got scene 10 with a transition that goes to scene 11, which has transitions to scene 10 and 12. And scene 12 has a transition back to scene 11. But these are these very uniform scenes. As you can see, they fit my screen size exactly. And so we've got overlapping transition areas. So here's what happens. I already demonstrated this once, but let's do it one more time. If I go from 10, I don't have that fade yet, so it's a little bit less apparent here, but you'll see I'll just be like, I'm in level 12 and back to level 10. It's like, hey, what on earth happened to level 11? And you might say, well, maybe you just screwed up your transitions in level 11, Mike. Well, let's try that out. We'll come here to level 11 and I should go to 12. Hey, that worked. But now I can't get back to 11, right? And vice versa, if I run this again, scene 11, and try and go back to 10, that works, but I can't get to it. Because we're just having that issue, right? Scene 10, you enter here, it loads scene 11. Player is still right here, so it triggers scene 12. And then it finally does this, okay? There's a pretty straightforward fix to this. I butted my head against the wall for a while against this one because I felt like there was a different way, or I felt like there was a better way, and I tried many. There is a pretty simple solution. It just didn't feel quite right, but it is a great solution, and it is right. I just didn't understand why, but if you guys don't like it, maybe you can suggest a different solution. So go ahead and drop that in the comments as you look at this. But let's look at our level transition. What's happening is we've got on our load scene finished, we're going to go ahead and just connect this signal. And this can happen before the player gets moved. And there's a couple things at play here. One is simply that our player is a character body 2D, and this is an area 2D. And what happens is when we update the position of anything that's physics related in Godot, that update happens at the end of the frame. So it doesn't happen until all the code for that frame has run. Okay, so we're already one physics frame behind. But in addition to that, these areas tend to also be behind by a frame. So by that logic, we could be behind by 2 physics frames in our detection of collision with one of these areas. And so that, in essence, is what's happening. And there's a pretty simple fix, like I mentioned. So what we're going to do is we're going to come in here to our onload scene finished. This is on our level transition script. And before we connect, we're first going to disable the monitoring of this node. So we'll say area2d.monitoring equals false. Okay, so even when we enable it, it's not going to detect any collisions while this is set to false. And then what we need to do is we obviously need to set it back to true. But before we do that, we need to wait. And like I mentioned, we can be 2 physics frames behind. So we're going to say await. In fact, I think we're pretty much always exactly 2 physics frames behind. So we'll say get tree dot, and then we'll say physics frame. And then we'll simply copy and paste this line. And there we go. Now this is going to disable itself. It'll connect that signal, but then it'll wait 2 frames before it enables itself again. That way, for 2 physics frames, it won't do any collision detection. So now if I come to scene 10 and I run this, we should be able to go to scene 11. Boink. And we can go to scene 12, just like that. Okay. So there's a simple but super important fix. If you didn't implement that, you might not even see it right away because you might not have that overlapping transition area problem until later down the road. And then you're going to be confused like, well, why am I? And in fact, in the action RPG series, I had that issue for a while and I didn't recognize it. And it took me so long to introduce a fix. There's still probably a lot of people who don't know how to fix it. So anyways, sorry guys. If that's you, I'm sorry. Now we fixed that. We could say we're done, but I'm going to make this whole dang thing working. So if you've stuck with me this long in the video, I appreciate you. Let's just make this pretty and then we'll wrap it all up. Okay, let's go over to our scene manager. We can take this test label and delete it. I'm going to keep this control here, but I'm going to rename it. I'm going to call it fade. Okay, so what we're going to do is we're going to build a nice fading transition that works depending on the direction that we enter, right? It's dynamic in a sense. And I'm going to take this fade control and I'm going to come up here to my, I guess to this anchoring here. And I just want to do the full rect option so that it fills my scene, my screen. And then underneath this fade, let's add a texture rectangle. Oops, right there. With this texture rectangle, for now, let's go ahead and have it fill, but we're going to have to make it larger here in a second. Essentially what we want is when we do a fade transition, we want to be able to do like a wipe or something like that. Now, if you don't want to do this part, if you like how it looks otherwise, then, you know, you're welcome to stick with that. But this is a fun way to make it feel a little bit fancier or more dynamic. So this texture rectangle needs a texture defined before it displays anything. And what we're going to do is we're going to use a gradient texture 2D. Now, what we're going to do though with this texture rectangle is we're going to make it larger than our entire screen. This is a simple way to get a fade animation. And so this method that we're doing is particular to the style of transition that we're going to do. You could use an animation player. You could use other things. We're just going to have a cool faded thing that we tween. But I'm going to come down here and in the fill style, I'm going to set this to square. And then I'm going to make the square start in the center and expand out. So we'll do 0.5 on those, the X and Y on the from. And then the 2, we'll do 1 and we'll do 0.5. on the other, just to make sure that it goes to the edge here. You see how that's drawing to the edge? Now, additionally, we need this to be completely black box in the center. And we're going to come in here, and what we're going to do is we're going to take this black stop, and we're actually going to come in here into our raw data. So you can move these, right? And you can see that it's going to update these values here. See how those change? We want this to be at exactly 0.5. Okay, so that's going to give us a box that goes halfway out and then it starts to fade. And we'll change our other fade color to black and drop the alpha. So now we have this. We've got a texture that is just black that fades out. Okay, so far so good. Now you can adjust the color of this as you see fit. In fact, one other way to handle the colors would be to make it white and have it fade to white, but transparent still, right? And then you could just come in here, and if you decide you want to change it, it's as simple as going to visibility, modulate, and picking a new color. So then if you wanted, I don't know, whatever, any color you want, right? A purpley gray, very dark. Then that's what we could set it as. Pretty easy to recolor. But we're not yet done with this gradient because we need it to be higher res. It's really bandy and kind of gross. And we want it also to be large and spread outside. So what we're going to do, we're going to make the size of this rectangle 3 times the width and the height, because what we want is we want this portion and this portion and this portion to all be equal to the size of one screen. And so here's how we're going to do this. And in fact, I'm going to have to adjust my stops, I think, too. Yeah, I do need to adjust my stops, right? Because I just described in 3 equal sizes. Right now I've got 1 that's half, and then these are each a quarter. So let's go back into our raw data. This should be like, what, 0. Is that like 3, 3, 3, 3, 3? I don't know, right? Okay, and then that way we've got 3 equal sections, but obviously this is our whole screen. This needs to be bigger. Okay, so now is where we'll make it big. So we're going to set the width and the height of this to 3 times. Now, based on my project settings, I've got a, let's see, a viewport width of 480 and height of 270. So let's go 480 times 3, boink, and 270 times 3. And look at that glorious fade. You can see that it's completely gray here in the center and it fades out. We're never going to see these corners, so you don't have to worry about those. But if we're fading up, down, left, or right, we've got a bit of fade that's just big enough, right? So we can go and fade it like that, or we can go and fade it. So essentially what we're going to do is when the level loads, we're going to fade it in, and then once it's done loading, we'll fade it back out the other way. It'll be just like that, okay? Be kind of fun. This is a pretty simple way to do a fade. I want to make sure I have my transform reset back to, yeah, that looks good. This automatically sized it where I need it because of how we set it up. But if not, you may need to, you know, adjust your rectangle position so that it's not up in the corner or something like that. Okay, we've got our fade set up. Now we need to come into our SceneManager and add code to animate it. And now I've already made a comment where we kind of need to do some of this, right? We need to fade the scene out and we need to fade the scene in. And we're going to just use some tweens to do this. But as I mentioned, you could use an animation player. And then instead of like waiting for process frame, you could wait for animation finished before you do the scene load, things like that. But like I said, we're going to do a tween for this one. I think tweens are just way too cool not to use. And so right here, actually, I'm going to do it up here at the beginning. We want to just get a couple settings so that we have everything we need to make this work. And one of those is a fade position. And I'll just call it fade underscore POS. And that's a vector 2. And I'm going to set it to something for now, but we need to actually calculate this. Because we need the fade position to be different depending on the direction that it's moving, right? Because like I was demonstrating when we were dragging that around, if we leave the level on the right, then we want the fade to come in from the right. And then when the next level loads, we'll have it continue in that direction. Okay, you don't have to do it that way, but that's how I want to do it. And likewise, top, bottom, right? So let's make a function to do that. We'll have a function called getFadePosition, which will return that vector 2 that we need. Now this fade position depends on the direction, right? dir, which is going to be a string. Now this, let's go ahead and create and declare this new position variable, which is a vector 2, and it's going to equal something weird. Let's make a new vector 2. And essentially what we need to do is we need to move it like a certain distance, right? Like twice its size to the right or left. Okay. Or we need to start it from there. So what we'll do is let's first start by calculating what that offset max could be. And so that's going to be, what's like 480 times 2? We could just type that in there actually, right? And then 270 times 2. Hey, there we go. Let's be lazy. That's our new vector 2. I'm going to go ahead and return this. But we're going to alter this as well because obviously we're passing in a direction and it's going to be a string. We're going to make a match statement here. So we're going to match our direction. And the first case is if it's left. So if the string that we pass in is left, I hope it's spelled right, then what we're going to do is we're going to multiply our position. Not capital P. I don't know why I gave it a capital. We're going to multiply our position by a vector 2. So that we can alter it, right? Because what we need is if we're on the left, then we actually need it to go all the way to the left. And so we'll do a -1 on the x-axis so that instead of being to the right, it's to the left. And then we'll multiply it by 0 on the y, okay? So that it doesn't move up and down. So that's essentially going to give us this. So if it's left, it's going to move over here. So if we want it on the right, it'll move over here, which will be like double that, you know, that value on the x positive and 0 pixel movement on the y. Okay, so let's go back to our script. I'm going to go ahead and just copy this. Right. And then we can just paste that in there. And now this will just be times 1. Okay, I'm going to copy both of these. This is probably a dumb idea, but now it can also be top or bottom or up and down. How do we want to call this? Let's call it up and down because that more accurately describes the direction that the transition is looking. Okay, so for both of these, we're going to multiply the x value by 0. No movement on the x, but if it's up, it's -1 on the y. We're going to move it up. If it's down, it'll be 1 on the y. Okay, we've got a function to calculate the fade position. Let's go ahead and plug that in here. And of course, we need to pass in this direction, which we're going to use this string, which by default, we're doing nothing with. So let's just go ahead, we'll pass it in here. And this is a time when we need to go back to our level transition. And where do we pass that in? Let's see. Let's find our onPlayer entered. We're passing in left, so it's always going to do left, right? So we can come back and fix that, but at least we know that'll work because that's one of the values that we're checking against. So, okay, we'll come back to that. There we go. So what this does, this first line, is it's going to get that position, and then we're going to come down here and we're going to grab our fade. We don't have access to this fade, huh? We just named it. Let's get an on-ready reference to the fade. Okay, there we go, fade. So now we can say fade dot, and I'm gonna do this. I'm gonna say visible equals true, because we're probably gonna want to hide this at times, right? And so I'm gonna copy that. When we load this scene, we'll set it to false, so that this fade thing is not going to be visible by default. But then when we start our transition, we'll make it visible. But we also need to set the direction. But because we're going to use a tween, we can use that tween to set the direction, right? And so here's what we're going to do. We're going to use the same kind of tween in a couple different directions. And we're going to call that same tween twice in this one script. So I'm going to use a function to do the tween. And let's just go ahead and do this. Let's just make a new function called fade screen. And what we're going to do is we're going to pass it two directions, or two positions. We're going to do a from and a to. So we'll get from, which will be a vector 2. And to, which will be a vector 2. And because we're going to wait for this to happen, we want to await this. We need to make this something that we can await. And so we can say that this returns a signal. Okay, and of course it's giving us an error because it doesn't currently return a signal, but we'll get there in just a second. So I'm going to delete this pass so that we can replace it. But we'll go fade dot position equals from. Okay, so we're starting. This is where we're going to actually set the position. And then we'll pass this in here, right? So we're going to move our fade to the from position, and then we'll make a new tween. You just use this create tween function. And then we're going to go tween.property, or not property, but tween.tween property. Right there. Okay, so what do we want to tween? We want to tween our fade. We want to tween in its position. And we want to tween it to the 2. And then we need a fade speed, and we can maybe just plug it in here. I'm going to make this fairly short, but I'm going to stick with something like 0.2, but I prefer even a little bit shorter than that maybe. It's going to be quick. We don't want it to take a long time. Okay, so we're going to have a tween, and then here's what we're going to do. We're going to return tween.finished. See, this is a signal, and we're just returning the signal, right? And then what we can do up here in our code is we can say, now it's not, we can do it here before or after this, but let's go ahead and assume we want to do it right here. We'll say, call our fade, what do we call it? Fade screen. And then we've got to provide these two vectors. So we're going to take our fade position that we calculated up here, right? And we need to tween it to vector 2.0. So when we're fading, we're moving it to this position of 0, 0, right? If we look at this right now where it's covering the screen and look at the transform, the position is at 0, 0. Does that make sense? So we're going to go calculate where to start, tween it. And because we made this an awaitable signal, we can say await fade screen, just like that. And then we can replace this await get process frame. Okay. Now, if we test out our game, let's see if this works a little bit. Hey, it faded in. It didn't fade out, right? Because we didn't finish our code. So let's go ahead and copy this. And then after our new scene is ready, we've got this comment to fade it. I'm going to fade it again, but this time we're going to swap it. We're going to go from our vector 2.0 because that's where we're at. And then we're going to go to the fade position negative. So it's the opposite of how we started. Okay, so now this should go the opposite or continue, I guess, in that direction, right? And if we run this again, we should get a full transition. Nice and smooth. Now it's always going the same. It's always going left to right now. I mean, even if I go down here, it's going to go left to right. But that's because in our level transition, we're passing in this value here. So let's go ahead and replace this with a function. We'll call it get transition direction. But that function doesn't exist yet. So we need to create it. I'll just come down to the bottom of my script. Now this is going to return a string, and we'll do another match statement. Here we're just going to match our location, which if you recall, I mean, it's been a while. It's been like 3 years since we wrote that. So if you forgot, I'll forgive you. But we're matching a side, and we've got 4 values. So if it's left, then we'll return, and in this case, we want to just return a string of left. And we'll just do the same for the others. And I'm going to do top next. And then we renamed these. If you recall, I call them up and down. So we'll return up. And then lastly, I'm not going to specify side bottom because we're going to need a default. So underscore is the default. So if no other matches match the above, then do this. And we'll return that down string just like that. Okay, so now we've got that in there. If we go back to our SceneManager and look left, right, up, down, we should get different vectors. So let's go ahead and run our project one more time. And now our transitions should match the direction we're going. Whoosh, whoosh. Nice little wipe. And if for some reason your scenes took a while to load, meaning it was on that black screen, like let's say it took 10 seconds. I mean, it's not going to, but if it did, then the way we wrote our code is pretty dynamic because it's going to come in here. Or let's see, let's go to our script. And it's not going to fade again until this new scene is ready. And so if it means it's loading for 10 seconds, it's going to take 10 seconds before that signal gets emitted. And then you'll get your fade out. Okay, so that's nice. It'll keep that black scene. You won't get any weird janky thing happening if for some reason you've got a longer load time. And I didn't really show the up and down, but let's test those out, make sure that they're working. So when we go down, it wipes up and vice versa. I can't quite jump up, can I? Woo! Let's go ahead and work on that. That's one little bug. I think that was working before, but it's not working right now. And actually, I know why it's not working. And it has to do with what's happening here in our transition scene. So let's talk about that. So now we've introduced some awaits in here. We're fading the screen. And even though it's a minor amount of time, 0.2 seconds, right, is what we've coded right now. We can make it quicker if we want. That is time happening. And one thing we didn't do during this transition is we didn't pause the game. So technically, our player is still moving during those 0.4 seconds, and that's enough to mess with his position. Okay, so I think we can fix the issue we were seeing there by simply coming into here and pausing our game. So what we can do is when we start, we can get the tree dot, and then let's see, I guess it's just paused, huh? Equals true. Go ahead and copy this. And then we don't need to unpause it until we're done with our fade. Set this to false. And there's a little bit of other cleanup I want to do here. You know, we made this visible. I think we should also hide it again when we're done. So visible equals false. Paused equals false, right? Okay, so we're just doing a little bit of cleanup. Let's go ahead and take a look at how this feels now. Uh-oh. Oh no. I paused the game, but guess what? This script isn't running when it's paused because if we look at our scene, its process mode is set to inherit. We need to make this always run. Now this should run just fine. Okay, good. Right, I don't know that we've really covered that a whole lot, but this mode, if it's set to inherit, then it's going to be paused if the game is paused and vice versa. If you set it to always, it doesn't matter if the game says it's paused, it's going to keep running its script. Okay, so we can come in here. Now we should be able to go down. Woo! And now the jump is back to working as expected. Now, sometimes you'll have issues where you can barely transition and you might need to give the player a little bit extra boost. You know, if you wanted to, you could come into your script and do things like if the level transition is of a, upward direction, then you can add some extra velocity to the player. You could do things like that. As you can see here with our game, it's not really necessary because he's got enough jump velocity so long as you give the right amount of space, right? But there we have it. We've managed to make a complete and fairly robust level transition script and scene. So, you know, you can obviously do other fun things. If you wanted to, you could make it so that it adds text when you go to a new screen, or any number of effects or audio or anything that you want. And I hope you guys have learned something new. I know this has been a long one, so thanks for sticking around. I'm trying to make these things modular and compact enough as far as concepts that, you know, even if you're not following my series, you can get what you need out of it to build a complete feature for your game, no matter what it is. So thank you for watching. Feel free to drop a comment below. Please subscribe to my channel if you haven't already. It helps me grow. It helps you know when new stuff is coming out. And in the next video, we're going to take these scenes and we're going to add parallax layers to add a sense of depth and immersion. And so you'll want to see that one. So thank you for watching. And as always, we'll see you next time.